For decades, industrial design has followed a strict sequence. You build the raw shape of an object first, and then you dress it up. You hide the bare metal behind a layer of paint. You bolt the light housing onto the front. You wrap the hard interior in soft leather. But treating functional properties as secondary additions forces heavy physical compromises. Every applied part requires a way to attach it. An external headlight means routing shut lines, inserting rubber seals to keep the water out, and engineering a plastic lens to cover the bulb. We are effectively treating essential features, like lighting and color, as temporary costumes that the core structure wears. 4 separate industry shifts crossed our desks today. They appear unrelated at first, but they all converge on a single change in how products are fundamentally composed. We are watching a mass relocation. The properties that designers used to bolt on at the end of the assembly line are moving directly into the structural material itself. When a material generates its own features, the external attachment disappears. The functional property now exists inside the structure. Take automotive finishes. BASF's newly announced 2026 collection removes the colored dye layer entirely. Instead of applying a flat pigment, they engineer a microscopic grid into the material. Light enters the structure, bounces around those tiny layers, and generates color based on how the waves intersect. The color isn't a coating, it is a physical reaction happening inside the structure. We see this same structural approach driving the 2026 interior design direction. Mood is no longer established by adding ambient lighting or soft-touch vinyl overlays. Instead, the mood is baked into specific physical irregularities. The spec sheets now demand hammered and wavy glass, oak and worked pine selected specifically for their visible grain, and heavy boucle wools. By embedding the texture directly into raw materials, manufacturers ensure durability and a graceful aging process. It is a quiet rejection of the fragile plastics that force an annual product refresh. The emotional response to a product is no longer adjusted late in the process. The mood is entirely locked in the moment you select the raw material. This logic scales up to the entire physical architecture of a product. Look at Acura's Nexera Vision concept, which completely discards the traditional lighting module. Acura uses phantom lighting. The ultra-thin lamps sit behind what appears to be solid bodywork. The car suddenly projects its graphic signature directly through the opaque surface, remaining invisible until it turns on. When you delete the physical lens, the voids disappear. The complex support web snaps into a clean, continuous grid. This allows engineers to completely reroute the front crash structure, sending it straight through the old light module space. The Nexera carries this architectural inversion into the cabin. Instead of mounting front seats on heavy rails, they bolt them straight to the floor, moving the steering wheel and pedals to meet the driver instead. Deleting a single component, like a plastic lens, eliminates the structural detours required to support it. The overarching physical architecture of the vehicle becomes instantly simpler and vastly stronger. Even abstract properties like lifecycle management are becoming physical. Consider the Fairphone Gen 6 Plus, a device that entirely rejects the post-launch service network. If a traditional phone breaks, you ship it for repair. Someone melts the adhesive and forces the shell apart. It's a logistical problem solved after the product leaves the factory. Fairphone relocates that capability. They engineer the repair process natively into the joints. A user can open the casing and swap a module with their bare hands. The metallic joint effortlessly tops open. That mechanism has to be mathematically plotted before a single piece of metal is ever tooled. Product longevity is no longer a logistical service handled by a warranty department. It is a physical property of the hardware itself. Relocating a property, whether it is a glowing emblem, structural color, or a modular joint, into the material is not a styling detail, it is a structural commitment. In the old model, surface-level design choices happened late in the timeline. Now, these decisions slam forward. Architecture is entirely settled in the first weeks of conceptualization. If a team delays core architectural choices, they face an exponential penalty. Integrating structural features late in development guarantees failure. Moving features deep into the structural material pulls the entire weight of a product's success directly to the start of the timeline. The first decisions carry the heaviest consequences. When properties are baked into the material, the concept stage margin for error drops to zero. A generative model that drifts or surprises a designer becomes a liability. The visual must precisely match the structural engineering to ensure features like phantom lighting actually work. Platforms like Depix provide this necessary consistency, ensuring the early concept matches the final physical product. Digital sketches offer complete financial freedom. Physical molds dictate absolute permanence. Manufacturing demands bridging that gap flawlessly. The choices made in the concept phase are now the sole determinant of the final product. You have to see every angle before you build.